All right, this is practice 6, the topic of factoring. Well, there's actually 7 types of factoring that we need to go over and just kind of review. The first type is the GCF, which is common factors. 2 and 3 are both trinomials. One's with the A in front, which is the simpler ones. And number 2 is when A is not 1. And then we got the perfect factoring problems, the sum and difference of cubes, and grouping, and then completely factoring. So let's go over each one of those. All right, so common factors. Again, you're looking for the GCF on this. So if you look, I got 2 examples. So if you look for the GCF, notice what's common here is a 3 and an X. And so when you factor out, this is your GCF, greatest common factor. And so when you factor that out, you're literally dividing this. So in your mind, you don't have to write this, but in your mind, you're dividing both of these by 3x. That's really what you're doing. So you divide that by 3x, you're left with an x. Divide this by 3x, you're left with a 2. Now, the way to check this is simply use the distributive property. So if you were checking this, you would just simply take 3x times x, that's 3x squared, 3x times negative 2, that's minus 6x, which is the original product. So you can easily check it by the distributive property. All right, so this next one, again, look for the GCF. Notice all of the numbers. I have 8, 6, and 2, so the GCF is a 2. Notice the common x's is just 1x. Notice the common amount of y's is y squared. So again, that is your GCF. So you're going to divide each of those terms by 2xy squared. So you're going to divide this by 2xy squared, and you're left with 4x cubed. Notice there is no y. You're going to divide the second one by 2xy squared, and that's going to be 3x squared y. And then notice you're going to divide the third one by 2xy squared, and you're left with y squared. And again, you can check it by using the distributive property. And then just one quick comment, there should not be anything common between all 3 of those. If you still have an x common with all 3 of them, that means you didn't factor out the GCF. Or if you still have a number common with all 3 of those, or a y common with all 3 of those, then you did not factor out the GCF. All right, that's method number 1, common factors. The second type of factoring is with trinomials when A is 1. So this one, again, notice A is a 1, and then so what you need to do on this is simply, this is going to be 1x, and then you look at the last term, and what times what is 12, positive 12. And again, in your mind, you start thinking of 12 times 1, it could be 6 times 2, it could be 3 times 4. I also want you to consider all the other ones, the negatives, so negative 12 times negative 1, negative 6 times negative 2, and negative 3 times negative 4. Those are all the possibilities that multiply to give you the last term. But then you look at the middle term, and only one of those will add together to give you positive 7. So positive 3 and positive 4. Now, if you FOIL this, you will simply end up with the original problem. So x times x is x squared, x times 4 is 4x, 3 times x is 3x, 3 times 4 is positive 12. And notice the 2 middle terms end up add together to be 7x. So notice this is the original term. So you can always check it by FOILing. So trinomials with an A is 1. Those are kind of simple as long as you're multiplying and adding facts are in order. All right, number 3, factoring trinomials when A is not 1. Well, there's several methods that teachers teach you. The most common ways that I refer to and several teachers is the grouping method, also called the AC method. So let me go over that method first. So here's a trinomial, 6x squared plus 7x minus 5. You take your A and your C and you're multiplying together, and that's what I have here, negative 30. And in your mind, you start thinking of all the possible factors that multiply together to give me negative 30. And I listed them, but I'm only interested in the ones that add together to give me positive 7. Well, it's this one right here. I have a green arrow beside it, and it's negative 3 plus 10. So what you're going to do is this step, a very crucial step, you rewrite the trinomial into a 4-term polynomial. So instead of positive 7, you're writing those two terms that add together to be positive 7. So notice I have not changed the value whatsoever. And so now what you're going to do is you're going to factor by grouping. And grouping is you look at the first two terms and you factor out your GCF, which is 3x, and what remains is 2x minus 1. You look at these next two terms, what's common between those two is a 5, and then you factor that out. Now the cool thing about this method, I want you to notice 2x minus 2x minus 1, 2x minus 1, notice they will always match, and so that's what's pulled out of there, and then what remains is the 3x plus 5. You can see the 3x, then the plus 5. And again, the way to check this is to FOIL. If you FOIL your answer, I want to keep saying that, FOIL your answer and make sure it actually equals the original trinomial. Now that's method number 1. Method number 2 is called the guess and check, or some books call it the trial and error. Now this method is quicker once you get used to it. It may seem very long and like tedious, but once you get used to it, you can literally go straight from here to here in your head without any work whatsoever. Now, since I already know the answer, it's going to be kind of easy to do this, but the general idea is this. So what you're going to do is you're literally going to guess the answer. So again, pretend that we don't know the answer. So the way to do this is you look at your first term, 6x squared, and you think of what times what is 6x squared. Well, it could be 6 times 1, or it could be 3 times 2. And again, it could also be the negatives, but let's stay with the positives here. So and generally speaking, you start with the ones that are closer. So I'm going to start with 2x and 3x. And then what you want to do is look at the last term, and the last term could be multiplied together to be 5 and negative 1, or it could be negative 5 and positive 1. It's called the guess and check, so I'm literally just going to guess one of the terms. And again, try not to look at the previous answer. So let's just guess this one right here. Let's just guess negative 5 and positive 1. Now, if I FOILed that, it would not equal the original answer. So then you kind of cross that method out. This one does not work. And then you try the same numbers again, but notice I'm going to put negative 5 there and positive 1 there, because the order does make a difference when A is not 1. So if you FOIL this, then you would see that it does not equal this. It does not equal this, so you would cross that method out. And this is called the guess and check. You have to be quick at FOILing. So you guess another one. So you take 2x and 3x, and again, I'm still staying with 2x and 3x. I'm hoping 2x and 3x are the right ones. If 2x and 3x are not it, then I have to try 6 and 1. So I'm going to stay with 2x and 3x, but now I'm going to go to this one. It's positive 5 and negative 1. So I'm going to put positive 5 and negative 1. And then, again, I could put positive 5 in the other parenthesis, but I'm going to just start with positive 5 on this one. And if I FOIL this, it does not equal this one. It does not equal this one, so I'm going to cross that one out. And then, so then you try 2x minus 1, and then 3x plus 5, and you FOIL that and see if it works, and it does. And again, that may seem like a very tedious, because you're just guessing and checking. It may seem tedious, and it may be the 4th guess, the 5th guess before you actually get it. But I will tell you, the more that you practice that, you will get faster at this method. And usually within the first or the second guess, I can usually get it. So I would encourage you to try this method. It is a lot quicker if you're, again, very fast at FOILing. So that's how to factor trinomials when A is not 1. So let's go to number 4, how to factor perfect polynomials. Well, first let's start talking about binomials. All right, so binomials, if they're perfect, again, what I mean by perfect is if you look at your first and your last terms, they're both perfect. And so, and again, notice this is only a binomial, which means one is going to be positive and one is going to be minus. So then you basically say what times what is 4x squared, which is 2x, and then what times what is 9, which is 3 and 3. If you FOIL that, you would see that this equals that. I keep saying that. Make sure you FOIL it to check it. Same thing with this example. Again, I noticed the first term and the last term, they are both perfects. What I mean by perfect, they're like perfect square roots. So this would be 4x and 4x, and this would be 9 and 9. Because it's a binomial, one is positive, one is minus. Check it by FOILing. Let's go to perfect trinomials. And again, notice the first and the last are perfect. And so what you're going to do is, and notice everything is positive here. So I know both of these will be positive. So 2x, 5. And let me emphasize again, check it by FOILing. Same thing here. The first one is 3x, perfect. The next one is 7. But notice this middle term is a negative sign, so these are both negative. And let me say it again, check it by FOILing. If this number was anything other than negative 42, even if this is perfect, it wouldn't work. So you have to check it by FOILing. Make sure you check it by FOILing. All right, the sum and difference of cubes. All right, if you happen to notice that it's a binomial and the first term and the last term are both perfect, notice you follow this formula. And this little formula will get you to factor the sum of cubes. And again, this is called the sum of cubes just because we know we have a sum. And notice if you follow this formula, what is being cubed at the very beginning, it's a 1x. 1x times 1x times 1x is 1x cubed. And then notice this, what is being cubed is a 3. 3 times 3 times 3 is 27. So you just simply follow this formula, and notice this is, a is 1x, so this would be 1x here. All of the a's are 1x, so this would be 1x squared. So you just square it. And then plus b, so plus 3. So I'm just following that formula. Minus a times b, so this would be minus 3x. And then plus b squared, plus 9. If you multiply that out, you would see that it does equal the answer. The same thing with this. This is the difference of cubes, again, because we have a subtraction sign. Notice this first term, a is 2x. 2x times 2x times 2x, it's 8x cubed. And notice this second term, it's 5. 5 times 5 times 5 is 125. So you're just going to follow this formula. So this would be, this literally would be a is 2x minus the b, which is 5, a squared, so this would be 4x squared, plus a times b, which would be 10x, and then plus b squared, 25. And again, if you multiply that out, you would see that it's the original problem multiplied out. Now, just one quick thing, how to memorize this right here. There's like a little acronym, SOAP. This stands for same, opposite, always positive. So notice this is the same sign, this is the opposite sign, this is always positive. Same sign, opposite, always positive. Grouping is the last method. Well, it's the next to last method, but it's grouping. You do this with 4 terms. And again, we kind of already covered it. So you look at the first 2 terms. What's common between that is x squared. And look at the next 2 terms. It's a 4. And then notice these will have something in common. And then what remains is x squared plus 4. And this cannot be factored anymore. This cannot be factored anymore, so that's the final answer grouping. The final thing is complete is just a mixture of the GCF and another factor. So if you notice the GCF, it's 2x, so you factor this out, and what remains is 4x squared minus 25. And then notice this can be factored to 2x plus 5 and 2x minus 5. It's a combination of the 2. You can see the next one, I factored out the GCF. and then after that, I factored it to them.